Let's try it again. Let's see. Which object represents a negatively charged particle? Well, it wasn't A, so I thought there was supposed to be a pattern in it, so let me try it again. I got it backwards. B. That's what
Object A represents a positively charged particle because the field lines are moving away. Object B represents a negatively charged particle because it would attract a positive charge. Object C is uncharged because no electric field lines are shown.
Oh yeah. I had it backwards.
Let's quickly cover safety for this lab experiment. First, you always want to make sure that you've got your goggles and your lab coats when performing the experiment. Next, we want to make sure that your behavior in the lab is purposeful. You want to use caution when connecting circuits to avoid any electric shock. Next, you want to make sure you don't drop any magnets. Obviously, dropping something on your toes, your fingers will hurt, but dropping the magnets will also decrease their strength over time. So please try to handle them carefully. Don't bring any barred magnets near computers, computer monitors, audio tapes, or any other magnetic devices. Strong magnets can actually destroy these devices, and we don't want you being responsible for those kinds of damages. Always make sure that you disconnect circuits when they're not in use to prevent them from losing their charge and also keep them from overheating. And finally, no matter how big or how small an accident you may have, always make sure to report them immediately.
Okay.
Take a moment to think about what you should do as part of this safety protocol for this laboratory experiment. Refer back to the student guide if you need to. In this lab, you will want to wear safety goggles and a lab coat, even though you won't use any chemicals. Use caution when connecting electrical circuits or using electrical current, and avoid dropping magnets or getting them near computers or devices.
Nice. Now it's time for the lab.
Welcome. You're now ready to begin your lab exploring the connection between magnetic fields and electric fields. By the end of this virtual lab, you will have been able to examine how an electric current can generate a magnetic field. Let's begin.
Okay.
Here are some of the materials you'll use in this virtual lab. Scan through the list before moving on.
Iron filings, 2 balloons, clear packing tape, okay. A 6-volt flashlight bulb.
Just read through it and do like you do.
Here are the rest of the materials that you'll use in this virtual lab.
Student guide. Okay. Looks easy enough.
If you don't have a copy of the student guide, which contains the data sheet, click the link.
I didn't mean to click that. I meant to click yes.
Be sure to follow along in the student guide for this lab and record all data on the data sheet.
It should be saved to my... Oops. 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 I'm gonna do that. Let's click this. Downloads. And then it's right here. Just once, I can just view it from right here. Okay. Sir. Thank you. Okay. Yes, I have a copy of the student guide.
In the first part of the lab, you will observe and describe magnetic fields. In this step, you'll figure out which materials are magnetic. Magnetic materials are attracted or repelled by magnets. Make sure you follow the on-screen directions. Start by dragging the magnet to the paperclip.
It's gonna grab the paperclip. See? It's going to not grab the wire because of the coating. It's not going to grab the ruler either. And it will not grab the pencil. Will grab the stapler though.
Once you've recorded your observations in Table A of your student guide, continue on to determine the polarity of magnets.
Okay.
In this step, you'll identify the north and south poles of a magnet. Make sure you follow the on-screen directions. Start by dragging one magnet to the other so that their ends align.
Haha, I still got notes. Oops. Okay. Easy enough. They're going to attract each other because that's positive and that's negative. They're going to repel each other this time, probably. See? They repel each other. Okay. It's going to point that way. And this one's going to point the same way. See? See that? Yeah. It's going to point that way. It's going to point that, yeah. It's going to point down that way. And this is going to point up. Or nope, down. It's going to point up. Now this is going to point the other way. Yep, same way. Okay. It's going to point down. 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 Up. Nope, that way. Down, or up. It's up that time. Up. And down. Nope, it's up. Let's do the last one. It's going to go up. 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 Okay. Continue.
Once you've labeled the poles and direction of the compass needle in Figure 1 of your student guide, click Next to visualize the magnetic field lines of the magnet.
You can see it. There's where it's going in, and then going out, and then spreading out.
Now you'll visualize the magnetic field lines around the magnet by shaking iron filings around the magnet and seeing where they settle. Make sure you follow the on-screen directions. Start by placing the sheet of paper over the magnet.
It's going to show you where the magnetic field is, obviously. Okay. Oh. Then we're going to take those. See? There it is. The magnet, and then it's going out and everything there. Okay. Sir. Yes, there's patterns there. They're all going out.
Once you've drawn the pattern created by the iron filings in Figure 2 of your student guide, click Next to explore electric fields.
So I'm just supposed to click it again. Yeah, I get it.
In this part of the experiment, you'll explore and describe electrical fields. Make sure you follow the on-screen directions.
Static electricity.
Start by labeling the balloon.
So apparently I can't click. See? Yeah. Tracks the water.
Once you've finished recording your observations in Table B of your student guide, click Next to observe the interaction of electric fields.
It's not doing anything to the wall.
Now you'll examine what happens when two electric fields interact. Make sure you follow the on-screen directions. Start by labeling the blue balloon.
It's probably going to repel each other, most likely. That's going to be C. Okay. Simple enough. Oh, yeah. So, I'm dragging it. See, it repels.
Once you've finished recording your observations in Table B of your student guide, click Next to test for a magnetic field around the balloon.
Okay.
Now determine whether you produce a magnetic field when you create a static charge. Follow the on-screen
I
directions.
hit my knee.
Start by dragging the cloth to the balloon.
It's not doing anything to the compass.
Once you've finished recording your observations in Table B of your student guide, click Next to detect electric currents with a coil and simple galvanometer.
Oh, I've heard about those. Those are so cool. Galvanometer.
Now detect electric current with a coil and simple galvanometer. Follow the on-screen directions. Start by dragging the wire to the compass.
Oops. We're going to wrap around the coil here. Make a coil. Okay. Take our tape. We're going to wrap it around the coil. Perfect. And it does mess with the compass.
Hello.
Drag the bar magnet. See? And it point to... Look at that. It switched ends. Oh, crap. Drag it to the wrong place? Oh. Doesn't do anything to it.